With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Today our question is the coordinates of the foot of perpendicular from origin to a plane are 1, 2, -3. Find the equation of the plane, right? So we have given, let's say this is our coordinate axis, right? And we have given the perpendicular point on the plane from origin is 1, 2, -3. That means if this is our plane, right, then perpendicular from origin to this plane will look like this, right? And we have given the point up to which the normal is extending. So this is at 1, 2, -3. This is at 0, 0, 0, right? We can say that 1, 2, -3 will lie on the same plane. Now let's consider some other points on this plane as x, y, z, right? Now since O is the origin and coordinates of foot of perpendicular, let's say this is our O, this is N, and this is some general point P on the plane, right? So now we will find out the direction ratios, right? So direction ratios of the perpendicular, which is ON, will be position. ON is your direction vector, right? So position vector of N, we will write here that x2 minus x1, y2 minus y1, z2 minus z1 will be the direction ratios of the line ON, right? So here we will subtract 1 from 0 from 1, right? So 1 minus 0 will be for x-axis, then 2 minus 0, and then -3 minus 0. So 2 minus 0, -3 minus 0, right? This will be our direction ratios for the perpendicular, which will be 1, 2, and -3, right? Then direction ratios of this line NP. Direction ratios of vector NP will be position vector of P minus position vector of N. So position vector of P is x, y, z, and for N it is 1, 2, and -3. So direction ratios will be x minus 1 for y-axis, then y minus 2 for z-axis, and z minus -3. So it will become z plus 3 for z-axis, right? Now we know that ON is the normal, right? This is the normal to the plane, and NP is any line lying in the plane, right? Lying in plane. So we can say that ON and NP will be perpendicular, right? ON and NP are perpendicular to each other. So we will write down the condition of perpendicularity says that if two vectors are perpendicular to each other, then their dot product will also be 0. So we can say that ON dot NP will be 0, right? Therefore, and here we write since ON is perpendicular to NP, so therefore ON dot NP will be 0. So vector ON will be the direction ratio vector of this. So 1, 2, -3. So we'll write here 1, 2, -3. We have to write it in terms of vector to take the dot product. Then for NP it will be x minus 1 I cap plus y minus 2 j cap plus 3 bracket close is equals to 0. Then we will take dot product x minus 1 I cap, then 2j cap into y minus 2j cap, then minus 3k cap into z plus 3k cap. So we will have a k cap here, right? So we can say that this will become x minus 1 plus 2 into y minus 2 plus minus 3 into z plus 3 is equals to 0. It will become x minus 1 plus 2y minus 4 minus 3z minus 9 is equals to 0, and this will give us x plus 2y minus 3z minus 14 is equals to 0. So this will be our final equation of the plane. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.